Alright, this is Cal 1, Applications of Differentiation, and we're going to be talking about what differentials are. And maybe, if I feel like it, we'll give a definition of differentials. Anyway, so this is just going to be an introduction to differentials, and then further on into the lesson, we'll be working a lot of examples. And so what we're going to do here is I'm going to start with a picture. So we have a curve, and this curve here is defined by y is equal to x squared, and then I've got a tangent line at this point right here to the curve. And here's the whole idea of this differentials that we're going to be talking about. We need to understand the concept of the tangent line approximation. By using points on the tangent line to actually approximate a value on this curve right here. Now we're going to use we're going to look at look at an example here. Let's say that we go out to where x is equal to 2, and as you can see, my y value is 4. Now remember, this is y is equal to x squared, so 2 squared is 4. And then we pick where x is equal to 2 on the tangent line right here, and its y value corresponds to 3. I don't know if I mentioned it or not, but this is the point right here, 1, 1. Well, take a look at the y values. We have 4 and 3. So if we were trying to get an approximation of the y coordinate, that's a difference of 1, and I don't think that's going to be a very good approximation. But as you see, as we get closer and closer, okay, as our, this would be our delta x here, as it gets smaller, and we get closer and closer to this point here, the y values here, their difference is going to become smaller. So let's look at another one. We'll turn those off. And let's look at another one here. So this time x is 1.5. And as you can see, well, this is overlapping here, but the y value, so as you can see, y here is 2.25, and we have 2, and this is the point on the tangent line. So the difference between these two here is going to be 0.25. So you can see this approximation is getting better, I'd have to say, because this difference in the two y values is getting smaller. Alright, and of course we'll go ahead and now let's look at, okay, so we got the purple dot here, so we are now at 1.1. So as you can see, this is 1.1 and our y value is 1.21. Now let's look at the point on the tangent line, which you can't really tell because it looks like they're overlapping. Alright, so this is an actual point on the tangent line here, and that's 1.2. And if I remember right, this is 1.21. So you can see this is occurring just above, right, the actual point that's on the tangent line. So you could use the tangent line as an approximation when x is equal to 1.1. I mean, look how close they are. That's pretty close, right? So that's going to be the whole idea in the differentials, and of course you could go in this direction also, I suppose, but we're going to be staying above, up here above it, and that's really it. By using the tangent line to do an approximation. Alright, so that's basically the whole concept here.